Alright, so here we are with our 7-4 notes on two-way tables. So we're going to construct and interpret two-way frequency tables of data when two categories are associated with each object being classified. So taking a look at an example here, our two-way table is a definition of a useful way to organize data that can be categorized by two variables. So in this case, whatever it was that they were measuring, they have children saying yes or no, and adults saying yes or no. And they've put that in the two categories. So the question has two variables, and then the type of human, I guess, age, has two variables. The joint relative frequencies are the values in each category divided by the total. So basically we've taken every number in here and added it up. So 3 plus 8 plus 7 plus 2. And so that ends up being 20. And then to get that next number of 0.15, we take 3 and divide it by 20, and that's how we get 0.15. So, two-way table, it's made up, is usually what's going to be presented, and then the joint relative frequencies, add everything up and divide by and use that when you're dividing each section. So 0.15 comes from 3 divided by 20, 0.4 comes from 8 divided by 20, etc. Alright, so then we have marginal relative frequencies. So what's happened is that same category that we had before now has what we call the margins, right? And so once we have those joint relative frequencies, we can add the row across, add the other row across, add the columns down, and then we actually get our total over here, which is going to have to be 1, because otherwise you didn't have percentages that made sense. Alright, so again, you add the joint relative frequencies in each row and column. Then we have conditional relative frequencies, which are found by dividing the joint relative frequencies by the marginal relative frequency. And so this is what we are going to be solving here. So again, we're going to divide the joint relative frequency, which would be one of these guys here, by the marginal relative frequency. So perhaps one of these out here. And conditional relative frequencies are used when we are finding conditional probabilities. So just a condition that we're trying to find the likelihood of. So here we are with our first example. A reporter asks 150 voters if they plan to vote in favor of a new library and a new arena. The table shows the results. So the first thing they want you to do is make a table of the joint marginal relative frequencies. Oh, marginal and marginal relative. So they want you to expand this chart and make these into their percentages. So how do we do that? Well, we got to total it up. So 21 and 30 and 57 and 42 is 150. So that means that every one of these numbers needs to be divided by 150, and then we can make our joint frequency, joint relative frequencies. The marginal relative frequencies is then once we add each of those rows and columns. So taking to the next slide here, this again is coming from dividing by 150. And now if we continue by adding across, we're going to have 0.34. Then we're going to have 0.64. And of course that adds to 1. Oh wait, 66, because that did not add to 1. The next one is going to be 4.52, and then 0.48, and then of course that adds to 1 as well. So then they want you to do this next piece, which says you are given that a voter plans to vote no. So we're talking about this total here. Because anytime we're talking about given, that is going to be the bottom number there. What is the probability that the voter also plans to say no to the arena? And so again, we need the people that are within already saying no here to both of them. And so that means that our total is going to be 0.28 over 0.48. And that's going to be 0.58 or 58% likely. So again, just as we kind of discovered in our last set of notes, we're always talking about the given piece being tallied and then put in the denominator, and then that next piece is in the numerator. Alright, so let's see. The next one, we're going to compare conditional probabilities. A company sells items in a store and online and through a catalog. Yay! A manager recorded whether or not the 50 sales that were made one day were paid for with a gift card or not. So we're going to use some conditional probabilities to determine which method a customer is most likely to pay with a gift card. So notice that it did say 50 sales that day, and so that means that the total is going to be 50. And so we are going to, wow, that's a terrible 5. Okay. So we are going to take each of these numbers. Let's see, this one is 6 and 9 and 5. 9 and 13 and 13, and we're going to take each of them and divide it by 50. And so if we do that, we end up with these numbers. Again, all of those came from dividing by 50. And then from there we add across and add down and get our marginal frequencies. So let's see. Use the conditional probability to determine for which method a customer is most likely to pay with a gift card. So we know, again, given that it was a gift card, we want to know, is it more likely that they'll go on store, online, or in a catalog? And of course, because we can see that 0.18 is larger, it's going to be online, but we might want to actually be able to then reference their probabilities. So the probability that it was in store, given that it was a gift card, is going to be 0.12 over 0.4. And so that's going to be 40%. Then we have the probability that it's online with a gift card. And so that's 0.18 out of 0.4. So that's going to be 41%. And then the last one, the probability that they went to the catalog and then paid with a gift card, is going to be 0.10 over 0.40, or 1/4. Oh Lord, I was doing that wrong. They're not going to be over the same thing. They're going to be over their total over here. So 0.30, which is in fact 40%. It's just because I had the answer key here, but then I did one of them and realized it wasn't giving me that answer. So anyway, 0.26. Sorry about that confusion. So that's 38%. So anyway, as we saw that it's actually the more likely number, 0.18, this one is going to be more likely. So more likely paying online with a gift card. Which I find to be kind of cumbersome, because you usually have to enter in all those numbers and there's something to like rub off. Anyway, okay. So then we have our next example here. A juice bottling factory has some quality control technicians, and they're going to select some bottles, mark them as pass or fail, because maybe they're too tall or wide or whatever it is. The manager randomly selects the results of 50 tests and organizes the data by shift and result. And the table below shows the results. So they want you, of course, to make a table of joint and marginal frequencies. So, taking a look at what they said, it does say 50 tests, so we're going to divide each of these by 50. and then of course add across and down. So this one here I did not add apparently, 0.38, 0.28, 0.34, and then 1. Let's see if that actually is 1. Yep. And then, let's see, all the way down here is going to be 0.7. And then all the way down here, 0.3. And so that's 1 over there. So now that we know each of those, they want you to find the probability that a bottle was inspected in the afternoon, given that it failed the inspection. So again, given that it failed the inspection means that our total is going to be down here at 0.3. And then the first piece was inspected in the afternoon, and so we want this guy. So it's 0.08 over 0.3. And that's going to end with about 27%. And then the other piece asks you to use the conditional probabilities to determine on which shift a bottle is most likely to pass the inspection. Alright, and so this one, we're going to do the probability of pass in the AM, probability of passing in the afternoon, so we'll just call it noon, and then probability of passing in the PM. And so to do that, to pass in the AM, we're going to do like we did in the previous one, and you're going to take the pass value and put it over the total. So 0.28 over 0.38. Which is about 74%. The next one is going to be 0.2 over 0.28. And so that becomes 71-ish percent. And then the last one of passing in the PM is 0.22 over 0.34. So 65%. Alright, so which one is it more likely to pass in? And I guess that would be the AM. Apparently everyone took or drank their coffee or did their yoga or something. Alright, so that is two-way tables. Interesting. Again, if it talks about given, that identifies what column or row you're going to be in, and then you're looking at the piece within it to be over that. Otherwise, like the last ones we just talked about, if you're, for instance, in, which one was it? Well, we'll just talk about the last one. If we're going to pass in the AM, you go to the pass total, and that's down here. Sorry, the AM total, and that's down here, and then the pass on the top. Alright, so that's 7-4 two-way tables.